Okay, we've been working with HTML5 Canvas at the last couple of months here on Fridays, and I promised you in the new year, it's January 2014, we are going to start working with 3D stuff. And we're mainly going to be using Three.js, which is a JavaScript library created to make it easier for you to create 3D stuff. If you go to Three.js, that's THREEJS.org, there's a few more professional examples that they have here. Very cool stuff if your system can run it, and we'll talk more about that in just a moment. But not only do they have these examples, but they also have great documentation, and they also have the download package where you can download all the library files, examples with models, and a whole bunch of stuff from very basic stuff up to more advanced stuff, and we're going to go through a lot of that in this series. Again, a new video every Friday here on my YouTube channel. So go ahead. My recommendation is, first thing, go here, go to Threejs.org and start looking at all of these. Some of these things may or may not run well on your computer. Some of these work great on both mobile and desktop. Example here, I think this is one of the greatest that runs so smooth, even on my phone, is this little ping pong type game here. But look at through these, see what is possible using HTML5 and Three.js. Now, when working with HTML, we have HTML5 and working with 3D stuff. You have different options. You can use just Canvas alone. You can use CSS to do 3D stuff, and you can use WebGL. Now, I don't know all the technical differences, but I will tell you what I have read and a little bit of I experimented with is something like the CSS is probably the most compatible, but the simplest. It can't really do advanced stuff from what I've read. I haven't really messed with it too much. Mainly I've worked either with the WebGL or the Canvas, and we're going to be playing with both. So if I tag a video saying Canvas, it may or may not actually be using the Canvas. And I'll try to explain in each video when we're using what. But basically, WebGL is going to be the most advanced. It's going to allow hardware acceleration if your hardware is not blacklisted, if it's allowed, and we'll talk about that more in future videos. It's going to give you the best performance if your browser supports it. And as I said, CSS is the most compatible. Somewhere in the middle is just using Canvas, I guess. Using the Canvas, I can actually run some of these scripts on my phone. I'm running an older version of Android with Firefox, and the Canvas stuff runs, but not great. A few frames a second even for simple stuff. But of course, as this is still in early development, as we move on, you'll see better and better performance, better, more hardware added to the list of accepted cards for the WebGL. With your browsers, you can always override and even use blacklisted stuff. If you have a blacklisted driver, graphics card, you can still get around it and get it to work, but it may not run great. So anyway, there's a lot to think about, and we'll get into that. Play around with these examples. But now that I've talked forever, let's jump into the tutorial here. So here I am. I am in a folder. I will list out. I've got two files. I've got plain.html and a very minimal min.js. It's the minimal JavaScript 3.js file you need to run stuff. When you're working on bigger projects, you're going to want to download the whole package, go through it, and pull out what you need. But I've already extracted this one file for these basic tutorials, and we'll link to them. That way you don't get confused with other files from the package in these tutorials. Now, the plain.html is this right here. We'll go back to this. If I vim into plain.html, you can see it's a very simple HTML file so far. We have the HTML tags, the body tags, and we're loading up the script, which is in the same folder, so I just need to give it its name here in the script tags. Now we're going to start creating our own little script here. So let's go script. We'll open and close those tags so we don't forget to close them later on. And we need to create a renderer. So let's create a renderer object, var renderer equals new, and so we're creating a new, and this is something from the Three.js file that we've already imported. We're going to say 3.webgl renderer. Whoops. And it's very important to spell things properly. Also remember, things are case sensitive. 3 here has to be capitalized, W and web has to be capitalized, GL and the R here all have to be capitalized. So we've created an object, a renderer object. Now let's say renderer. So taking that object we just created, and let's set its size. Again, capital S there. And we're going to make something full screen. It's not going to be part of the web page. It's going to be the whole page. So we'll say window.inner width, and then comma, window, lowercase, window.inner height, capital H there. So we're just saying our renderer is going to be the full window, your full browser window, the width and the height. You could put in your own numbers in there, but we want it full screen. Now we're going to say document.body.append child, and we're going to take this renderer and just append it to our body of our page. So renderer, the object we've created, DOM element. So, and don't forget our semicolon there. So we've added our renderer to our page. Next thing we want to create is a camera object, because you can make a 3D scene, objects, and all this stuff, but without a camera, you can't see anything. Whenever you're creating a 3D world, you need a camera. That's what you're viewing. So var, we'll call it camera. And just remember that this renderer here and this camera here, they're variables we're creating. We can call them within reason whatever we want, but it makes sense to call camera, camera, or you can call it cam if you want to shorten it up some. And we're going to say create a new object from the Three.js package. We're going to say perspective camera. Once again, capital P, capital C. And then in here we're going to give it some parameters. Oops. We're going to say 45. We're going to say window.inner width / window.inner height, 1, 1000. Now what does all that mean? Well, let's have a quick look at the documentation from the Three.js website on camera perspective camera. So it gives you an example, pretty much what we just did here, and we'll be adding the camera here in a moment. So the first number, this 45, is the FOV, is the camera frustum, I'm assuming how you say that, vertical field of view. So just think vertical field of view. The camera aspect ratio, the near plane and far plane of the camera's frustum. So you might be going, what's a frustum? Well, it's a geometry term. If you go to Wikipedia here, in geometry, a frustum is the portion of a solid, normally a cone or pyramid, that lies between two parallel planes cutting it. Okay? I hope that helped you some. I think it's not too important in this tutorial, and considering I don't even really understand it, but I think it's just the depth it can view. So this one means basically as close to the camera, and the 1000 is as far away from the camera you can get. So basically if something is further away than 1000, whatever measurements we're using, it will be out of view. You won't be able to see it. I'm assuming it won't be rendered, which hopefully will help performance some. That's my guess. But just going through tutorials, 1 to 1000 is good for this tutorial. Now we need to set the position of the camera and its rotation. So we're going to say our camera object, and we're going to set its position, and we're going to set its Y position. We're going to set that equal to negative 450. And then we're going to set our camera's position dot z equal to 400. And we are going to set the rotation of the camera